Okay, DP11 Physics. Welcome to my home office. So, worksheet. But yeah, this is my name in Egyptian. It's on papyrus. Someone, a mom and her son I tutored, they brought that back from Egypt for me, which is pretty cool. Someone made it like on the street, on actual papyrus. Then there's something other here for my birthday. It's like Taurus coolness. And my physics books, some of them. Logic books, history of math. And there's more back there. It's not empty. There's actually books back there, and I can prove it. Evidence, reasoning, you know, like physics, where we prove things. See? Ta-da! Calculus, geometry, biology, more biology, chemistry in there somewhere. Okay, anyway, my home office. So, clipboard. Two hands. All right, worksheet. Since I have IB training, stuffy stuff, Monday and Tuesday, and the sub will be there. Make sure we do this. So, motion graphs and kinematics worksheet. The graph below describes the motion of a fly that starts out going left. So I'll do like two parts. I'll do some of this, then maybe I'll have dinner, then finish it later or tomorrow. So there's a few on here. I'll do this one first. So, velocity positive, velocity negative. That means velocity going one way, velocity going the other. Usually, positive is to the right, negative is to the left. And that's what it says. The graph below describes the motion of a flight that starts out going left, negative velocity. So, you know, just like with gravitational stuff, up is positive, down is negative. So also, like on that x-axis, right is positive, left is negative. Okay. That's what we usually do, but you can do it the other way if you would like, as long as you define it for a certain problem, so people are aware of the context. If you hide it in your head, it's too bad. It's wrong. We got to make it clear. But oh, and I'm tired, so I took my contacts out and put my glasses on. My eyes were getting tired, so my contacts were starting to not be as pleasant as usual. Okay, identify the section where the fly moves with constant velocity. Constant velocity means it stays the same. Where is the velocity not going up or down? Velocity goes down, stays the same. It's the same all this time. Then the velocity increases but not as much, decreases at a different rate, increases, right? Velocity is going down. Up to the right is positive, down to the right is negative. So, and when there's a change in velocity, what do we call that? Change in velocity in time? Acceleration. So I have one camera here and one camera here. My phone is a backup in case the photo booth thing messes up, as it's done sometimes. I find it highly annoying to spend 30 minutes making a video to have nothing done and my time wasted. So I learned to have a backup. So that's why I was like kind of showing it different places. Phone, computer. So when there's the velocity is changing, acceleration. So acceleration, 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 acceleration. No acceleration, no acceleration. Okay? So notice when the lines are a different slope, it's a different acceleration. Because acceleration is change in velocity with change in time. Therefore, in Well, because like V is A T plus V initial, that's like Y equals mx plus b. For a straight line, acceleration is the slope of the line, like, because that's where the m is. Y equals mx plus b. Y-intercept, slope, variable, variable, independent variable, dependent variable. So where does fly move with constant velocity? From 2 to 5 seconds, and from 21 to 22 seconds. And you know that's in the answer key, which is on the next page where it says answers. And then one of the answers is down there. But identify the section where the fly moves right, slowing down. So here, it's moving to the right, and the velocity is going up. Here, the velocity is still going up, so it's not slowing down. Here, it's slowing down. The velocity is 15, then 10, then 5, then 0. To go from 15 to 10 to 5 to 0, it's a slowing down. Okay? Then here, it's negative. Negative velocity is left. 0 is paused, so left, still left, left, then it's gone through 0, because it's gone away from where it started. You know, it starts out and it moves here and it moves left, but then it starts going back. Well, it doesn't happen yet, sorry, but it starts going left, but then it starts going back right when it's still over here. And then it probably somewhere in here it gets back to its starting point and then would go away more and then come back a little bit and stop. Something like that. So the velocity is moving away faster and faster, then it still moves away, then it still moves away, it's still going to the left, then it starts going to the right, and then eventually it'll get where it was, but it's still going to the right, and then it goes to the left. Okay, that's how it's moving. So left, right, right, left. So it's moving to the right and slowing down from 15 to 18 seconds. Moving to the left and speeding up, that'd be here and here, because the velocity is changing. So, because it's speeding up, still the velocity is speed in direction. If you're going to the left, but going faster in absolute value, you're speeding up to the left. When does it fly at rest? When it's got 0 velocity. At rest means not moving, as we've seen. When you throw something up, it stops and comes down. It's at rest right here, and right here, and right there. Like at 6 seconds, at 18, and from 21 to 22. What is the average velocity of the fly between 0 and 15? So average velocity is total distance and total time. So and we're looking at average velocity as opposed to, so we get displacement as opposed to distance. And so, because we're going to see from where it starts to where it ends, average velocity from 0 to 15. So 0 to 15 seconds. The average velocity is velocity it would go at in 15 seconds and end up in the same place. How fast could it go in 15 seconds and end up in the same place? That's the average velocity. So we do total distance and total time. The average total distance, total time, and the distance it travels is the area here and the area here, because, whoops, don't go dark computer, okay, there. the computer screen is about to go dark and I have to like open it up, password again and all that. So remember, like D equals VT, or with IB stuff, distance traveled is velocity times time. Okay, and when we multiply two numbers together, that's like getting the area of a rectangle. Length times width. So people a long time ago, Galileo for example, and others, Galileo knew from people before him, they knew that to figure out distance traveled, you can get an area, we can get a problem in physics, in algebra, and treat it like a problem in geometry. Multiplying two numbers together is like getting area. And since we prove the area of a triangle from the area of a rectangle and parallelogram, the same thing would apply. So we get the area here, and then you're going to generalize. In physics, getting the area under a curve is going to give you an important value all the time, or above the curve. So if we get this area, we got the distance it travels, and then here, and this is negative and this is positive. So you can do it in different ways. Divide it into a rectangle, into triangles, and get the area of the three parts. I'm going to do parallelogram. Area of a parallelogram is 1/2 base 1 base 2 times height. And the height is the distance between the bases, the parallel sides. This is parallel to this. The distance between them is 10. That's the height. And then this length is 6, and this length is 3. So this base is 6, and this base is 3. Half of 10 is 5. 9 times 9 is 45. Area is 45. Okay. Then this part is not a trapezoid, so I can't do the trapezoid formula. I guess I have to do a trapezoid and two triangles. So if we go down here and here, I have a trapezoid and two triangles. Or you can go across and have three triangles and a rectangle. But this is 1 by 10. Okay. Area of a triangle, 1/2 base times height, 1/2, 1 times 10, and that'll be 5. This part here, here's 1/2 base times height, base is 3, height is 15. So 1/2, 3 times 15. We're going to have 7.5 times 3, 22.5, unless I did my mental math wrong. So, which is great. And then here, area, trapezoid. So, the parallel parts of the base, not the top and bottom this time. This and this are the sides of the trapezoid. Remember, trapezoid has two sides that are parallel. Those are the bases. These are parallel. We got 10 and 15. So, and then the height is the distance between the parallel bases, which is 8. Half of 8 is 4. 25. 25 times 4 is 100. So it's 100. So we got 5, 22.5, 100, and then negative 45. If we're doing average velocity, we've got to take where it goes into account. So the displacement would be 100 plus 5 plus 22.5 minus 45. Whereas if we were doing distance travel, we'd add these. Total distance is different than displacement. Displacement, as we talked about, is only where you start to where you end. So if I ran to the other side of the room, ran back, ran to that side of the room, ran back, and came here, displacement is 0, but distance traveled would be like, I don't know, what's that? 3 yards? Is that 15 feet or 10 feet or something? And let's just say 10 feet. That'd be like 40 feet. The distance traveled would be 40 feet. Displacement 0. Okay? So, kind of like here. And then the total time is 15 seconds. Or whoops, I had too much. We're supposed to stop at 15. Sorry. You should have told me. Come on. Wake up, people. So, 22.5 we don't need. Whoops. Minus 45. Told you I was tired. Took off my glasses. My contacts, I mean. Glasses are on. There. Because we go from 0 to 15 seconds, not 18. Alright, but that was fun. Anyway, at least for me. So, although I'm getting hungry and eating would be more fun. So we got that over 15. And so 105 minus 45 is 60. 60 over 15. That's like 15 minutes out of 60 minutes, quarter of an hour is 4. So 4, I guess, meters per second. Yeah. So the thing could have done all this stuff, gone back and forth, blah, blah, blah. But on average, if it would have just gone 4 meters per second for 15 seconds, it'd end up in the same overall place, okay? Just like, instead of running back and forth and expending all that effort, if I would have just stood here, I would have ended up in the same place, okay? So, that's the average velocity, 4 meters per second. The distance traveled by the fly in this time interval. So the displacement is 60, but the distance traveled would be just like running back and forth. Instead of standing here, the distance traveled 100 plus 5 plus 45, which is 150. So the total distance traveled was 150 meters. But it undid part of the time, so it's just like 60. The average speed in the same time interval. Then we do total distance and total time instead of that. And we get to go this far in 15 seconds, total distance to total time, average speed, S for speed. I guess I'll write it out. Speed. So here again, we're getting to see the difference between distance and displacement, speed and velocity, stuff like that, to see it and see what it means. So the average speed would be 150 in 15 seconds. So it'd be 10 meters per second. Okay. Average acceleration. So the average change in velocity, total displacement from 0 to 22, times on the fly changes direction, acceleration versus time graph for the fly. So we got in the same time interval. So we have average acceleration. Let me see. I'm tired and so I'm hungry and I'm like, my brain's turning off. So this is my computer screen. Put in my password. There. Okay, still recording. Good. So we got that, and let me see. Need that for total displacement. And then we got 22.5. I'll do this and erase it all. Well, I remember that. We had 22.5. 15. Yeah. And then, because for part I, and the whole time, here's the triangle. 18 to 21 is 3. It goes down to 5. And so the area here, area 1/2, 3 times 5, 7.5, but negative, and then that was negative. And then we added it all together to get the total displacement. And so we had 5 plus 100, 5 plus 100 plus 22.5 minus 45 minus 7.5. 105 minus 45 is 60. 22.5 minus 7.5 is 15. So total displacement is 17. So I can erase that. When does the fly change direction? When it's going from left to right, like here, it's going left and going right, changes here. And then here, it's going right, and then it goes left. Because positive is one way, negative is the other. Then acceleration versus time graph. And so, that's that part. So I can erase this in a room. And okay, then that stuff's done. This direction, then average acceleration, we get average velocity. So it starts there, ends at 0. I don't know, I'm breading for some reason. It's not coming to me. I'm not stupid, I'm just tired, as you know. But acceleration graph, look at that. So here, we got, as I say, y equals mx plus b, and v is a t plus u, like, you know, so we get the slope of a line, and that's our acceleration. So here, we drop -10 and go over 2. So it's just algebra 1, okay? what is the slope of the line? Because acceleration is delta v over delta t, just like m is delta y over delta x. So we go down 10 and over 2. 10, negative 10 divided by 2 is negative 5. So negative 5 until there. Then it's 0 from 2 to 5. So we're there. Then to go from 5 to 7, a distance of 20, up 20 over 2. You go up from negative 10 to 10, that's 20, and over 2. 20 divided by 2 is 10. So here, acceleration is 10. Then from here to here, we go from 10 to 5, up 5 over 8, 5/8. So down here somewhere. Then we go down 15 over 3. It's negative slope. 15 divided by 3 is negative 5. So down here again at the negative 5. Then we go down 5 over 2. Negative 5 over 2 is negative 2.5. Halfway in between. Then up 5 over 1. So it's 5 again. Then 0. And that's what they're showing there, I assume. They should have got the same thing that I did. Okay. Then erase. So average acceleration. So we got total velocity, total time, do acceleration, you get that. Final velocity. So I'm not brained right now. I have to do that with the next worksheet. When I think about it after I eat. I'll do the other one in a different video. Velocity versus time. And acceleration versus time. I'll do it tomorrow because I'm too tired. I'll probably eat. And then all the blood's going to go to my stomach. And I'm tired. And I'm already tired already. I'd rather eat than go to bed. I can go to bed, but I just would like to eat. So, I'll do that other part later when I'm awake. All right, so there's part of the worksheet. Peace.